Next, we'll talk about the scan to CAD inspection process. First, I'm going to want to import a nominal data file. I'll choose my Import Nominal Data button. Here's a look at all the files that we can import. We can import scan data as well as CAD as a reference file. I'm going to select our demo block and import it. When I mouse over these faces, you can see that these are actually CAD faces. This face tells me it's a plane. This face tells me it's a sphere, and so on. The next thing I want to do is import some scan data. We can either scan directly inside the software and get live deviation results, or what I'm going to do is import some pre-scanned data. Now, the scan data in the CAD will never be in the same spot, and we'll have to apply some alignment steps. This is where we'll start building our inspection feature tree. The first step will be a rough alignment, or automatic alignment. I'll accept it. And our first step has been added to our feature tree. The next step will be a datum alignment. I'll choose 3 datums, and we'll accept the alignment. And when I accept this, you'll see in the bottom left-hand corner that the software is searching for scan data pairs. When it's done searching for scan data pairs, it's actually associated every CAD face to a scan data face. So all the evaluations have already been made. We just need to dimension them. The next thing we'll do is we'll make use of our section mode. Cross-section mode will allow us to make sections in 3 ways. The first way is offset from a base plane linearly. The next way is rotation, and for this way we'll need a central axis as well as a base plane, so allow us to rotate around a part with an axis. And along a curve will allow us to pick any CAD curve and slide along it. We'll choose offset. Now I can select either a CAD face or a reference plane, drag it into my part, and you can see we get live deviation results when we do this. I'll go to my next step. Here we set up the minimum acceptable distance for deviation. And here we have the opportunity to add comparison points. We can simply just click on our CAD faces in order to get our comparison points. After we accept our section setup deviation parameters, we enter into 2D GD&T mode. Here you can see we've got a grid paper background, and we have our CAD faces and deviation available. Now I can choose my datum tool to establish datums for features that require datums, or I can choose my smart dimensioning tool, which will allow me to actually select any CAD face I want to and establish a smart dimension. So if I just want to know linear dimensions or intrinsic dimensions for certain features, I can just click on the sphere, place the tag, and now I know whether this sphere's size passes or fails based on our tolerance table. If you want to adjust the tolerance, you can simply click on one of our tolerance boxes and assign a new tolerance. The CAD information and the scan data will be compared, and an evaluation will automatically be made. Now, if you have a feature that you can't directly touch on the CAD, what we can do is use our reference geometry tools. For instance, if I want to make a center line on this part, I simply choose vector, choose my method as average, select my 2 CAD faces, and you can see an orange center line has been placed. Now when I go to my next step and accept it, if I zoom all the way in, my dotted line is my actual center line, and my solid line is my nominal center line. Now this reference geometry can be used with Smart Dimension. So I can ask the software to tell me how far is this sphere from the center line? How far is this edge from the center line? I'll accept it. I'm going to adjust the location of some of these tags. Now we can also adjust what these tags display. If I click on a tag and I right click and say Annotation Display Control, this allows me to display and take away whatever information I want. So for instance, for a Smart Dimension tag, I'm now displaying the standard representation, nominal, and actual value. If I wanted to add some more information to it, I simply select it from the left-hand side and say Apply. Now we've got our nominal, our actual, and our deviation. Here I'll just choose my nominal and my deviation, and I think that makes sense. Great. Now I'll exit section mode. You can see that the section information is retained and displayed in the appropriate position. If we want to hide it, we simply go to our model tree, drop down our section box, and hide section 1. Now pay attention to our feature tree. You can see that another element's been added, and that's a cross section. The next thing we'll do is we'll enter into 3D GD&T mode. RapidForm's XOV is up to date with all the ASME Y14.5 2009 GD&T tags. So you'll find a number of different 3D GD&T tools in here to allow you to dimension your model to your print. I'm going to establish some datums in 3D by selecting datum 1, datum 2, datum 3. All I need to do is select a face and then place the tag. 2 clicks. Now that I have some datums established, I can start using GD&T that will reference them. For instance, position. I can select any CAD face, place my tag, and you can see the fit was automatically displayed. We'll turn off my mesh for clarity. Here I can add a tolerance. I can choose a pattern, and it will go and find the rest of the features associated with that pattern. Choose a material condition, as well as datums. So here we're establishing a feature control frame and a GD&T tag. So we have 2 components here, our location and our feature size. I can also use our smart dimensioning tools in 3D. For instance, if I want to know the angle between these 2 faces, I can click the 2 faces and place the tag. Maybe I want to know the position of this cylinder with respect to that cylinder. Click the 2 faces and place the tag. Also, if I have 2 off-axis features, I can click the 2 features and place the tag, as well as adjust my alignment. So maybe I want to measure the distance between the 2 cylinders in X or Y axis. The tag will automatically adjust. Let's add some more GD&T. Maybe we'll add a flatness to the top. Click the face, place the tag, choose a tolerance. So normally during a demo, I'll place some tags on the part, place some 3D GD&T as well as smart dimensioning tags, and move on. So the next thing I want to do is talk about some of our color tools. I'll turn off my 3D GD&T and show you what our whole deviation looks like. So over on the right hand side we've got whole deviation. Now we can adjust some parameters for the whole deviation calculation. Maybe we want to use 50% of the data. Maybe we have a custom projection distance or a maximum deviation value. And in our second step, we can adjust our tolerancing. Maybe I'll make this 0.5 millimeters and make my green zone 0.1 millimeters. And I can choose to not display my tolerance zone and just get the deviation range. Now on the second step, I can actually just click anywhere I want and place a deviation tag. When I place these deviation tags, we're creating a system for repeatedly inspecting the same part with scan data. At the end of this routine, we'll show you how to replace scan data and get a new report. And when we make a new report, all of these points will be evaluated in the same spot as they were initially. So not only can we just do picking points, we can also choose some very controlled ways to lay out some comparison points. We can choose to lay points out around a curve. I can choose a CAD curve, choose a seed position, and then choose how many points I want to lay out. You can see them there. I can choose to maybe equally space them around that curve segment. And when I accept it, our comparison points will be displayed. And we'll go ahead and accept this step. Now if we look at our feature tree, you can see the story of what we've just done. First we made an automatic alignment, then we made a datum alignment, we made a cross section, did some 3D GD&T, and a whole deviation. The last thing we'll show in this video is report. So one of these last buttons is generate report. So we have our model tree on the left hand side and our target tree on the right hand side. Now we can adjust the placement of our target by clicking on one of our features and adjusting the position with these two buttons. We can also adjust what is in my report by selecting and deselecting them in my model tree. So maybe I don't want my alignment information in my report. I simply select it and it disappears. Maybe I also don't care what my scan data looks like and I just want my nominal data and the results. I can deselect that as well. We can also input our title block information and then create the report. Here's our report. I choose my Maximize button to enlarge the area that's viewable, and I can scroll through it. Here's our nominal data, our section information, as well as the readout from each tag, our 3D GD&T, as well as our 3D GD&T tags and results, and our whole deviation. Now these viewpoints are adjustable. If I want to add a new viewpoint here, I can simply go to my model view, open up my viewpoint, and add a new viewpoint. In this situation, it's just my CAD. But if I go back to my report, I can go back to my display tab and drag a viewpoint into my report. So these viewpoints are actually camera positions. So it's not just a screenshot. The next time you create this report for the next part will actually give us the same exact positions.